All right, so nodes and clients. So get through this, just a little bit of dry information, but I thought it was pretty interesting. I think the Ethereum website had a lot of really good, just like fast and easy, quick hitting points for it. But in case people aren't aware or can't really zoom into what we've been talking about, a lot of the updates that Richard's been saying that the reason that Ethereum, we're forking Ethereum, so that's the reason that a lot of this stuff that when we talk about Ethereum clients and nodes, all of it's going to translate one for one or just have slight differences to PulseChain. That's why it's important to understand the background of how these work, because essentially you're going to be using that to build upon for PulseChain. Like in the beginning, I said I was setting up an Ethereum node on testnet to get ready to figure out how to do it for PulseChain, because it's going to be like, okay, I'll just switch some stuff over, maybe do a little bit of nuanced PulseChain stuff, but all for all, it's a lot of it's the same stuff, the same clients, just forked and made for PulseChain, which is seems to be the bulk of the work that's going on to get preparation for testnet right now. So Ethereum distributed network computers known as nodes. Okay, sure most people are familiar with that. After the merge, one of the biggest things that happened was instead of proof of work mining, instead of just having a client that just mines transactions, you now have two different kinds of clients. You have execution and consensus layer clients, and they work together to basically keep track of the blockchain, validate transactions. You have the consensus part that does the validating of transactions. You have the execution clients that keep track of the blockchain data, and they work. And I'll pull up some diagrams here in a minute too, which maybe from here that make more sense too. But essentially, not this one. Yeah. So Ethereum client, beacon node, execution engine. Again, they kind of work together. You can have them on the same server, all that, and then peer-to-peer. They're talking to other nodes, pulling down data, syncing the blockchain, all of that. So a node is defined here as any instance of a Ethereum client software that's connected to the network. So again, post-merge, Ethereum consists of two parts: execution layer, which is where the execution clients live, and the consensus layer, where the consensus clients live. So again, there's a lot of different words and just different ways of saying it. The EL client, ETH1 client, but that's gone now. Just known as the execution client. And that's your Geth, Aragon, I think Besu. There's a few different ones there. And then the consensus clients, ETH 2.0, also known as beacon nodes. It comes with validator binaries as well. They actually implement proof of stake, and they enable the network to achieve agreement based on validated data. So that, again, they work together to make the network work as far as validating transactions, and everyone, the blockchain being synced and everything being good in that way. So again, all the complexity I talked about before, it just got super interesting. And like, if you're going to go try to set up a test net, some people are like, oh, don't use this one, use this one because this one's a mess. The merge basically split a lot of the documentation. It made some things that were pre-merge on the border, it's not so clear. So I've tried to dig through a lot of that to try to really help you understand how this stuff works. And we'll just go through just another minute or two. But node types, full node stores all the blockchain data, and then it can participate in block validation. That's how you get paid. Some of the fees are burned, and then the priority fees, instead of used to the wallet of the miners would get filled with the mining fees. Now there's priority fees that you can delegate to go to a wallet to get paid the different priority fees in ETH 2.0. And then the light nodes are basically, I won't go into the details. They do light stuff. They're not a full node. They help with just the scalability of the network in a few different ways. And then archive nodes, they store everything, I think, since Genesis. And they have a huge amount of data, and you'll probably never run one of those. So not super important. Now, why should I run an Ethereum node? And you replace Ethereum with PulseChain, same difference on this part. Benefits to you. So running your own node enables you to use Ethereum in a private, self-sufficient, trustless manner. You don't need to trust the network because you can verify the data yourself. So that's why when you set up MetaMask and you point it to a different RPC interface, you're just pointing it to another client. And you can set up a local client and point it to your own. So that's why when Richard says, oh, just set up your own client, you can run your own node. When he said that a million times, if you watch his, especially his older streams, that's what he's talking about. Like, you can just set up MetaMask to point to your own client because you've already verified everything. And, you can make sure nothing fishies going on because you're running it. Like you've already did all the hard work. So you can be even more trustless. That's why you want to run it. Again, you can use your Ethereum wallet with your own node. And yeah, if you're worried about privacy and Fura, all that stuff, you can use dApps more securely and privately because you want to leak the addresses to balances to random nodes. So again, like all your data is not getting sprinkled across the decentralized web if you run your own node and use it. You can, let's see, again, you can expose your own endpoints so other people can use them, but you got to be careful with that. Security, you got to get that right. There's like all these articles about people exposing nodes and they unlock their wallets and people steal money from their wallets. So you got to be careful with that. But you can run that just like Infura does, just like, you know, the ton of other RPC services and nodes out there doing. And then what most everyone is interested in is you can make money. You can stake ETH or Pulse. You can earn fees. You can do things like that with the network. So that's why you would want to run it. The network defense, again, running your node. And then let's see, again, the different clients, Geth, Nevermind, Besu, Aragon. So what I've been setting up is Aragon for the execution client, and for the consensus client, Prism. And that's so the four clients that Richard has been forking and using with PulseChain is GoPulse, which is Geth. So it's just a fork of Geth for PulseChain, Aragon, Prism, and Lighthouse. So the last two are consensus clients, which, yeah, here they are. They'll show on here too, Lighthouse and Prism. And I think that's just different synchronization modes. Again, I'll drop this in the chat if you want to go over it. I won't spend all the time on it, but I think this is a very succinct article that explains if you're interested in being a validator on Ethereum or PulseChain, this will tell you a lot of really cool stuff about checkpoints and different syncing stuff.
One thing I want to add in reading through there, yeah. I did not know that how decentralized. I mean, there's obviously multiple attack surfaces when you're talking about a blockchain, but the code base was a level that I had not thought of as being. So if one type of code base is exploited, there's many different code bases that Ethereum uses, and obviously PulseChain is going to use as well. But each of these have different client softwares. So I thought that was interesting. The code bases are all different.
Yeah, exactly. So basically Vitalik was like, hey, we're doing ETH 2.0 community. Go write some consensus clients. Here's a spec. Like here's the EIP or here's the spec. Go write some clients. And then okay, all of a sudden now you got Lighthouse. Now you got Aragon, or now you have Prism. Now you have all these consensus clients. And then I'm not sure when Aragon was forked or when they started using the Geth code base, but I believe it's built from Geth in some way. And it's just much fast. So like, why are we using it for PulseChain? Because it's faster. Just more efficient, a bunch of other advantages than using just Geth. But I would even ask too, like, so 4 different clients, we're setting those out to let people have a choice for being validators. I wonder what the Richard's validators can be using. I wonder if he's going to be using Aragon and Prism or Lighthouse. I wonder what they're going to be using too. But like why there's 4, why there's 2 of each kind, it's just to let the community decide what clients they want to what clients they want to use, and so everyone's not using the same one too. So diversity of clients is a whole thing you can read about as well. But yeah, I'm curious to see what RH is going to use for their validators. Should be interesting.